Okay, welcome, dear students. In today's class, we are going to discuss actually pseudo force. Okay, it is coming under the chapter that one laws of motion only. Okay, so today's concept is pseudo force. Okay, and it will be lecture number 1 on pseudo force, and I will try to just complete it within this lecture. Okay, and as you know, my name is Amarnath. So let us start pseudo force. Okay. So first of all, you see, if I give you one example, okay, say you are sitting inside a car, and your the driver, okay, started accelerating the car. So you get a push towards the back, okay. So as if someone is throwing you towards the back, okay. It is your experience. And one more experience, say if you are going in a high speed in that one on the highway, okay, if suddenly the driver applies the brake, so you feel that someone is pushing you towards the front of the car, okay? You go ahead, na? Like this, okay? That is also one second example. Sometimes you push back, you feel to be pushed back, and sometimes you feel to be pushing that one forward, okay? And one more thing in that merry-go-round type game, na? So if you rotate, okay, then you get a force toward that one outside, na? So as if someone is pushing you outside, radially, okay, radially outside, okay. All these examples are actually it is of pseudo force, okay. Actually, there are actually no forces acting on that, okay. But we feel like this, okay. We feel as if there is some force acting on me, okay. So first of all, pseudo force is not a force. First of all, it is just a feeling only, okay. You can say, or you can say that mathematical one correction only, okay. It is not actually a force, okay. It is force like a quantity only, okay. So actually what happens, you say you are going in the car, okay, on the highway with a high speed. So it means you are in the state of inertia moving, okay, inertia moving. If your driver applies the brake, the tires, because of friction, start stopping, okay, but you are already in the inertia of motion. So because of that inertia only, you try to keep moving, okay. No one is pushing you. Your back is already in the seat. So as the seat is stopped, so your back portion is also stopped. But your that upper part of your body, okay, it is the inertia of motion. So it will keep leaning outside, okay. So actually there is no force. This is the inertia only. Because of inertia, you are going ahead, okay. And same thing happens when a stationary car start accelerating instantly, okay. When a stationary car start accelerating instantly, you are in the state of inertia, but you are sitting on the car, so car is accelerated, it means your lower portion is accelerated, but the upper portion is stationary, and it tries to be stationary. So it feels like that as if you are pushing, somebody pushes you back, okay. But actually you try to be stationary only, your back portion is going up, okay, going forward. It's a feel only, okay. So actually pseudo force is first of all not a force, okay. It is some mathematical corrections, it is a imaginary force like quantity. We are going to discuss all these things, okay. So please write down pseudo force, okay. You see, say you know the Newton's second law, F equal to ma, okay. Here acceleration is a vector quantity, force is also a vector quantity. M is scalar, okay? M has no direction. It is mass only. Remember, this formula can be written, or this formula can be applied only by a man who is non-accelerating. Remember, this formula can be written by a man who is non-accelerating. Okay? Why I will say you. Okay? So before that, you write some definitions. Okay? I'll explain all these things. You please write down. It is a imaginary force like quantity. It is an imaginary force like quantity, or a mathematical correction which is required to be applied on a body when F equal to ma is written by a person. See, it a little bit of advanced knowledge, but you can easily solve it. Like I think, okay, the numerical part is very easy. By a person from an accelerating frame, okay, from an accelerating frame of reference. Okay, it is a long definition. I'll explain all these things step by step. Huh? See, say this is a car, okay? Say this is a car. Mass of the car is say 10 kg, okay? 10 kg. And the car is accelerating at say 2 meter per second square. Can you say what is the net force on the car from your general, from the knowledge you gained till now? A car of mass is 10 kg, which is going with acceleration 2 meter per second square. So what will be the net force on the car? Can you say? Can you try it? Net force on the car. What will be the net force on the car? If the mass of the car is 10 kg, respond me in the chat box, no issue. You need to find out the net force, okay? Net force. Net force equal to always, yes, always equal to mass into acceleration. So mass is 10 kg, it is already in SI. Acceleration is 2, already in SI. So equal to 20 and SI Newton, okay? So this is simple as that, okay? But now my question is that, say, who is observing this acceleration? Say it is observing by this person, okay, which is stationary, okay, which is not accelerating. But you tell me, if the person is also accelerates, say the person is also some in other car, okay, some other car. So say each the person's acceleration is say something AP, okay. But now you tell me whether the person will see actual acceleration of this 10 kg or some relative acceleration of 10 kg. Because it cannot see the actual acceleration. Actual acceleration can be seen only by a person who is stationary or non-accelerating, okay. See, say you are going this way, your velocity is 5 meter per second, but I am also going with 5 meter per second behind you. So for me, your velocity becomes zero because our separation is not increasing, neither increasing nor decreasing. Both are going. My velocity also 5, your velocity also 5. Okay. It means you are actually going. I am also actually going. But for me, you are not going because my separation is not increasing or decreasing. If the separation increases, then only I can say, na, you are going away from me. If the separation decreases, then only I can say, na, you are coming towards me. Yes or not? Exactly that way. Say this acceleration is 10 and this acceleration is also 10 going behind. So the acceleration of this object as seen by this will be 0 only, a minus a 0. No acceleration because they are going in the same pace. Okay. So that is why when an observer, this is called observer, okay? And already you know that we have some x, y, z axis, okay? Say this is the x axis, say this is the y axis, say this is the z axis, okay? Connected to the that one observer, okay? Is called frame of reference, okay? Means I am giving the reference on this frame only, okay? So what is frame of reference? It is nothing but the xyz coordinate attached with the observer, okay? Who is right, who is observing. Okay, this is frame of reference, okay? Okay, you see. So now you see, if the observer is accelerating, it means observer cannot see the actual acceleration, which is 2, okay? So it means the observer will calculate a wrong force, okay? The observer will calculate, see, force formula is mass into acceleration, but observer is observing some wrong acceleration, okay? So it means observer will calculate a wrong force, okay? Because he is not getting actual acceleration, na? So that is why we say that, always this Newton's law of motion is written by an observer which is not accelerating, okay? Otherwise, he will see a wrong force. But force is always real. See, this force is what? This is, what is the force on this object? It is mg only. That mg is independent of you or independent of some other student. One student is going fast. So it doesn't mean that the force of mg will be changed. One student is going slow, yeah, stationary. It doesn't mean that mg will change. Mg is mg only. But a person which is accelerating will see some other acceleration on it, okay? So it means he will calculate the force wrong, okay? That is why actually pseudo force is required so that an accelerating person also can write the equation F equal to ma. So how I will explain it, okay? No need to worry about it. So first you write the definition of pseudo force. First you write down, it is imaginary force. It is not a force. Remember, it is not a force. And again, I am saying F equal to ma. Ma means mass of the object and acceleration of this object only. Okay, not some other object. Whose acceleration is taken, mass also should be taken for that only. Okay, F equal to ma. Mass and acceleration of same object, not two different objects. F equal to ma. So you please write down pseudo force. Just you write down only. It is imaginary force, force-like quantity, or a mathematical correction which is required to be applied on an body when F equal to ma equation is written by a person from accelerating frame. Okay, say he is not stationary, he is accelerating. Okay, then he has to apply pseudo force. But how? Where, I mean, and what is the value of pseudo force? We are going to discuss it. No problem. So have you copied all these things till now?
Yes, sir.
Okay. One more definition you write. Inertial frame of reference. So what is inertial frame of reference? Say this is me. So as I am here, to I am associated with an coordinate system, na, x, y, z. Okay. So if its acceleration is zero, that is called inertial frame of reference. Okay. So you please write down a frame. Frame means XYZ coordinate. Okay, nothing else. A frame of reference because I am observing now. So which reference to me only object is going. Okay. A frame of reference is called inertial if its A is zero. Okay. Just you learn it already, nothing else. Okay. You just remember it. Okay. What is non-inertial frame? Non-inertial frame. Non-inertial frame of reference. So from the definition only you will understand. Huh? What is non-inertial? A is not zero. Okay. Means A is there. Say you in a bus. Okay, bus. And bus is accelerating. So whether you are in an accelerating frame or non-accelerating frame, accelerating. So it means you are non-inertial frame. Non-inertial means acceleration not zero. Okay. A frame of reference is called non-inertial if its acceleration is not zero. Okay. So you please write down direction of pseudo force. Direction of, first we discuss the direction. In which direction pseudo force is acted. Okay. Pseudo force. It is always acted opposite to the acceleration of the observer. Say the car is accelerating upward. So pseudo force will be taking place leftward. Okay. Sorry, backward. Okay. Like this. So direction of pseudo force is always, it is always acted opposite to the direction of acceleration of observer. Observer means who is observing you. Okay. So, and what will be the value of pseudo force? Okay. Please write down. Both are very important. Huh? Both are very important. Direction of pseudo force and value of pseudo force. Actually, numerically, pseudo force equal to mass of the body and acceleration of the observer. Okay. Numerically, you just remember this thing. Huh? Pseudo force is defined as the product of mass of the observing body. Mass of the body, write down just mass of the body. Mass of the body And acceleration of the body is not, it is not acceleration of the body, okay? It is acceleration of the observer, okay? Again, I told you, na? Again, I told you, F equal to ma, okay? F equal to ma. So, mass of the body and acceleration of the body only, because it is real force. But if it is pseudo force, then mass of the body, but acceleration of observer, okay? That is very important. That is why actually it is not a force, but its dimension will be force only, na? Mass into acceleration, mass into acceleration. So that is why it is called imaginary force, pseudo force, okay? But how can we apply in coming page we are going to discuss, okay? So you please write down all these things. And this formula also you write down, huh? This formula also. You please write down mass of object, acceleration of observer, okay? So both are O, no? So you do one thing. Wait, huh? You just write down F pseudo, okay? It is what? Mass of body and acceleration of observer, okay? MB means mass of body, okay? And AO means acceleration of observer. So I'll do one to that one numerical, and you will understand all, okay? And one more thing I am saying you, if you don't know pseudo force also, na, then also all questions of laws of motion can be done, okay? But uh, knowing pseudo force, na, technique of it is a technique only, na. So knowing pseudo force, we can do some difficult question also in future, okay? So just for the timing, na, you need just an idea of pseudo force only, okay? Not much thing required, okay? But I'll do one or two problems, no need to worry about it. So once you have completed writing, let me know.
What have you wrote in the AO for AO?
AO, acceleration, I have written in short, okay? It is acceleration of observer.
Okay, sir.
Acceleration of observer, okay?
Done, sir.
Okay. Everybody copied na all these things? Adita, Shikha to already told. Nitish, are you there, beta? Good.
Yes, sir.
Okay.
Copy, sir.
Okay. Okay. Can I go to the next page, Adita?
Yes, sir.
Okay. Okay. See. See, I'm taking in one example, huh? Simple example. This question already you have done, huh? But now I'll solve it using pseudo force, okay? Say this is a lift, okay? And this is a block. Say 2 kg block. Say the lift is accelerating upward. Acceleration is say 5 meter per second square. And I am asking what is the normal force, okay? Find the normal force, okay? On 2 kg block by the floor of the lift. Okay? See, again I'll solve it using that previous method. What I do, this is 2 kg. I write 20 Newton downward, normal action upward, and I know that acceleration is upward. So n minus 20 equal to mass into acceleration. Okay? Upward force minus downward force equal to mass into acceleration. So n minus 20 equal to 2 into 5. So it means n equal to 30 Newton. Okay. This is called normal force. And you can say this is also the apparent weight. Okay, I have already told you, na, if I place a weighing machine here, so this will be the reading. I have already discussed all these things. Don't forget the whatever we have discussed earlier. Okay, but I'll solve the same problem using pseudo force now. See, so what you do here, say this is the lift, na. So this is the block, na. Actually, in this problem, na, in this problem, you are observing from somewhere else. Okay, somewhere else outside the lift. Then only you can see the acceleration, na, proper acceleration. But now what I will do, I will sit on the lift only. Okay, now I am sitting on the lift only, and I will write the equation for the block. Are you getting it? So first of all, you tell me, first of all, you just tell me, I am sitting on the lift which is accelerating upward. It means I am accelerating upward. It means I am in inertial frame or non-inertial frame. You could understand that, remember or not, that word inertial frame, non-inertial frame. So I am in an accelerating frame, na? So accelerating frame is called non-inertial frame. Okay. It means I am in a non-inertial frame. Okay. So if a person is in accelerating frame, if a person is in accelerating frame or non-inertial frame, the person cannot write F equal to ma. Newton's second law cannot be written by him. But if he uses pseudo force concept, then he can write the equation. Okay. So that is the technique only. What the technique I am going to discuss it. You see. See. Say this is 2 kg object, na? Write 2 kg. You written. First you write all the real forces. So real forces, normal reaction is a real force. Okay. And mg is a real force. Okay. There are two real force, normal reaction and mg. Now, after writing all, see here only two, but I can give you in future classes a lot of questions. Okay. There may be some spring force, there may be some other magnetic force. Okay. You have to write all these things. Okay. All real forces. After that, you have to apply a pseudo force also, because you are in a accelerating frame, na? So you have to apply a pseudo force. Now you tell me, in which direction pseudo force applies? In which direction pseudo force applies? Pseudo force applies always opposite to the acceleration of the observer. So you are accelerating upward. You are here, and which is accelerating upward. So it means pseudo force will be downward, and pseudo force symbol is dot 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 dot. Okay, beta. So pseudo force will be downward. Okay. And what will be the value? Value of pseudo force? Pseudo force value will be mass of the body. Mass of the body. And acceleration of the body or acceleration of the observer? Acceleration of the observer. Here it is a coincidence that my acceleration and the object acceleration is same. But I am putting not the acceleration of the body. I am putting here acceleration of me, observer. Okay? See, I have done it. What are the forces I have taken? I have taken all real forces. Then I have taken the pseudo force. In which direction I have applied pseudo force? In opposite direction to my acceleration. Okay. And what is the value of pseudo force? Mass of the body 2 kg and acceleration of me 1. Okay. Now I can write the Newton's law. Newton's law is what? Total force equal to mass into acceleration. Okay. Total force equal to mass into acceleration, Newton's law. So upward force is normal force. Downward force is 20. Downward force is 2a. Must be equal to mass into acceleration. Mass into acceleration. Now you tell me, what acceleration I will see of 2 kg. For me, 2 kg is stationary or moving? What do you think? Say I am in the lift, and one container, one box is also lying on the lift. Okay, we are inside the lift. The object is going with me only. So what will be his acceleration? What will be its acceleration for me? It will be zero, na? That is called relative
Yes.
actually. Okay, zero. So I have to put here zero. Means I am seeing a false acceleration, wrong acceleration. Okay, which is zero. So 0. So ultimately what happens? So it is nothing but n minus 20 minus 2 into a value is already given 5. So equal to 0. So it means n equal to 30 only. Now a interesting question may come to your mind. Sir, it is so simply that one done in the first concept. Okay. So why so complicated concept is required? Okay. Now you will find little bit complicated, but in higher classes or in advanced problems na, and you will get it. Okay, that it is very important. Lot of questions actually na cannot be solved easily by that previous concept. Okay, but this can be easily done by the pseudo force concept. So that is why if you understand it or if you learn it, you will be always in advantage. Okay, so I am going to give you a similar question. Okay, and you please try to solve it with the same methodology. Okay, I hope you have copied all these things. Can I move?
Yes, sir.
Okay. But you will try to solve it with the second method, okay? Pseudo force method, but first method you know already. Okay. The question is, say inside the lift, okay? One object is there which is 5 kg, okay? And it is accelerating upward with 10 meter per second square. So find the normal reaction, okay? Between the block and the floor, okay? And the floor. So, madam, where I should be interested to sit. I think I should be sitting here, okay, inside the lift only, so that I can see the relative acceleration 0. Okay, the object is not moving at all with respect to me. Okay, so let us draw the free body diagram. Yeah, yeah. Yeah. बिल्कुल 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 बिल्कुल. No, it's in any. No. Okay. Yeah, absolutely correct. Absolutely correct. So this is 5. Okay. So first of all, write the real forces. Draw the real forces. It is fifth. It is a normal reaction. It is that one 50. Okay. Real forces done. Now draw the pseudo forces. Okay. Pseudo force is written like a dot. Okay. And it will be downward because my acceleration is upward. And what will be there? This it will be 5 into 5 is the mass of the object and 10 is the acceleration of me. Okay. And now I have to write the force equation. Okay, I know that net force equal to that mass into acceleration. But remember, for me, this time acceleration is 0. Okay, so upward force minus downward force equal to 0. So n equal to what? It is simply 100. Okay, with that normal method also I can get 100, and now also I can get 100. Okay, I'm going to take one more example. I'm going to take one more example. Okay. Say, say, uh, say this is a truck. Okay. Truck. Okay. On a highway. Say there is a block. Okay. Connected with a spring. Okay. And a spring has a spring constant, say 200 Newton per meter. Okay. 200 Newton per meter. Object mass is say 5 kg. Okay. They are stationary. Now the car has started accelerating with a equal to 10 meter per second square. Okay. So if the car started accelerating, so you know that the spring will be elongated. This is a practical experience, na? Because the block will try to be stationary, but the car is moving. It means spring will be elongated. Okay. So my question is, what will be the elongation of the spring? So this is my question. Okay. Find the find the elongation of the spring when the truck accelerates. with A equal to 10 meter per second square. Okay. Well, now you see. Now you see, if you observe from the ground, no, track is also going, mass is also going, spring is also going. But if you observe sitting from the car, okay, the situation will be very simple. Remember, I am sitting on the car, sitting on the truck. I am observer. I am sitting on the car, which is accelerating. So it means I am also accelerating, na? So I have to apply pseudo force. So let me draw the free body diagram of the block. Okay, on horizontal line only. Let me draw it. So the right directional will be spring will pull it, na? So it will be kx. As you know, the spring force is kx, na? Spring force fs. Fs spring. It is kx, where k is the force constant. I have given 200 Newton per meter. You remember, I think. X is the elongation, okay? It is a real force. And another real force is there, mg. Another real force is there, n. But we do not require about that mg and n because we are going to interested in the horizontal direction only, okay? So here, if you don't write mg, if you don't write n, then also no problem. But real force is done, but now I have to apply pseudo force. Acceleration is rightward. So pseudo force will be leftward. Okay, leftward. And what will be the value of pseudo force? The value of pseudo force will be mass into acceleration. So mass is 5 kg and acceleration of me. I am observer, na? Me. And which will be 10 because track is also 10. So I am also sitting on the track. So I have also acceleration 10 only. Now you see along the horizontal, right force is kx, left force is 50 equal to mass into acceleration. But for me, the object is stationary, now, so it means acceleration is 0. Actually, the object is not stationary. If I sit on the ground, can you say that object is stationary? No, object is going with the track. But if you sit on the track, you will see the object is stationary. So it means kx equal to 50. Kx equal to 50. Okay. So it means x equal to what? X equal to 50 by 200. Okay. Cut. So it means 1 by 4 meter. Okay. This will be the answer. Can you say what should be the answer? You can use the chat box. Pseudo force arises when an observer, means who is writing the equation, is in a inertial frame of reference, non-inertial frame of reference, rest frame, art frame only. Okay. So just tell me uh, what option pseudo force. Yes, Nitish, you are correct. Okay. If it is accelerating, so accelerating frame is called non-inertial frame. Okay. Accelerating frame is called non-inertial frame. This is the correct answer. Okay. Very good. It is a this is a memory based question. Okay, you have to learn only. Okay, if acceleration of a frame is 0, it is called inertial. If acceleration of a frame is not 0, it is called non-inertial. Okay, can you say this answer? Adita, you also please try. Okay, maybe wrong. No need to worry about it. Okay, beta.
Okay, sir.
Bindas. Don't take tension, beta. Okay, but keep participating. Okay, no need to worry. Okay. Yes, both are correct. Well, the direction of pseudo force is always same as acceleration of frame. No. Opposite to the acceleration of the frame. Yes. Perpendicular. No. Independent. No. Yes. Excellent. A bus suddenly accelerates forward. a passenger feels pushed backward. This is due to. So I think it is the easiest question. This is due to real force, inertia of rest, pseudo force, friction. Obviously, it is pseudo force. Okay. If somebody asks you why pseudo force is not a force, because it is a force-like quantity only, na? But if somebody asks you why pseudo force is not a force, then you can say that, sir, in pseudo force actually mass किसी और का, acceleration किसी और का. Mass is the mass of the object. M is the mass of the object. But acceleration is not the of the object. It is acceleration of the observer. That is why it is not force. But dimensionally mass into acceleration always becomes force only. So hence we say that it is force-like quantity, but it is not exactly force. So this is due to pseudo force. Okay. You go back. Okay. Inertia of rest also you can say, but they are not saying that initially bus was stationary. Na? They have not said the question that the bus was stationary. They are saying the bus accelerates. Accelerate means what? Say bus is going, okay. Say it is going with uniform velocity. Then increases the velocity. So that is also acceleration. Na? The best answer will be pseudo force. Pseudo force is proportional to mass of the body only, acceleration of the body only, product of mass of the body, acceleration of the frame. Frame is observer. Option D, velocity of the body only. Yes. Excellent, excellent. Okay. Answer is product of mass of the body, acceleration of the frame. Okay. Good going, good going. A lift moves upward with acceleration A. A person feels an additional force downward. Na? You feel like you are becoming heavy because normal action goes on increasing. Na? And this is due to real force by the earth, pseudo force, centripetal force, tension in the lift cable. So obviously, the chapter itself is the pseudo force today. Okay, so it is almost sure that it will be because of pseudo force only. Okay, so answer is that pseudo force only. Excellent, excellent. A car is accelerating at 2 meter per second square and a body of mass 5 kg is inside. The pseudo force acting on it is. I need to calculate only the pseudo force, okay? So this is the object, car is accelerating. So you are sitting here, then only you can see the pseudo force. Na? So what will be the pseudo force? Yes, 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 yes. Yes, yes, absolutely correct. Mass of the body, acceleration of the observer. 5 into 2, 10, 10, 10, 10. Absolutely correct. Which of the following is not true about pseudo force? Not true. Remember, not true. It has no origin in physical interaction. It depends on mass of the object. It arises only in inertial frame. It is required sorry, it is required to apply Newton's laws in accelerating frames. Okay, little bit wordplay type. Okay, you have to read it properly. But remember, it is not, which is not true, not true. They are asking, which is not true. C is not true. Not true. Yes, yes, yes. It is not true because it arises only in non-inertial frame. D is true. It is required to apply Newton's law in accelerating frame only. Okay. And all are true only. It has no origin in physical interaction. Okay. It is imaginary only, na? Zero force, is there any force? No, na. It's just like imaginary quantity, okay? As if someone is pushing, giving me that one, okay? Like that. Excellent. A train is moving with constant velocity. Pseudo force on the passenger is maximum equal to mg. Zero depends on direction of motion. Train is moving with constant velocity. The pseudo force on a passenger is maximum equal to mg equal to zero. Remember, constant velocity, constant velocity. Okay. Constant velocity means acceleration zero, okay? So there will be no pseudo force, no pseudo force. Zero, zero, zero. Yes, 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 yes. So it will be zero, zero, zero. Yes, yes. Okay, acceleration zero. Okay. Okay, guys, on that note, I want to end up today's class. Okay.